Hello all. Good morning. So today we'll start with chapter number 9. So chapter number 2 is completed as I just asked you about that, and we will exercise, like we will discuss the exercise, and then we will jump to chapter number 9. So do not worry, I'm going to explain everything in chapter number 9 because I know that this topic is completely new to you. So yeah, no need to worry about it. Let's start from this line. Yeah, so in the previous standards we have seen that organic and inorganic compounds are the two important types of compounds. So two important types of compound. Now the question arises is, if organic and inorganic are two types of compound, what is organic compound, right? The first question that should arise in your mind is, what is organic compound? So let me tell you about organic compound. Any compound, any molecule that has carbon and hydrogen in it are called organic compound. Very simple, right? Any compound that has carbon or hydrogen in it is called organic compound. You can also search about it, like what is organic compound. If you will search on the Google, you can see any large class of chemical compounds in which one or more atoms of carbon are covalently linked to atoms of other elements, most commonly hydrogen, oxygen or nitrogen. So these are called organic compounds. If you still have doubt, don't worry, we are going to learn about organic compounds only in this chapter. So then let's go to the next line. Except materials fabricated from metal and glass, soil, several other materials from foodstuff to fuels are made up of carbonic compounds. So if you don't know, let me tell you, petrol, kerosene, this all are also a part of organic compound. Okay, so the essential element in all the organic compound is carbon. So the most important, not only I should say, but the essential, like the necessary element that is found in all organic compound is carbon compound. Okay, about 200 years back, it was believed that organic compounds are obtained directly or indirectly from the organisms. I hope you know what are organisms. So it is saying that like 200 years before, it was believed that organic compounds are obtained from directly or indirectly from organisms. However, however, after synthesis of organic compound urea from an organic compound in the laboratory, the organic compounds received a new identity as carbon compounds. So 200 years before, people used to believe that organic compounds can only be found from organisms, either directly or indirectly. But then something came. What it came? In the laboratory at one day, some scientists, synthesis means they tried from organic compound urea and from an organic compound, and they received a new organic compound. Okay, so they synthesis means they try to produce with the help of organic compound urea. Urea is nothing but you can say fertilizers. Let me search from Google what is urea so that you get a better understanding of it. So yeah, a colorless crystalline compound which is main nitrogenous breakdown product of protein. Okay, you can see this one, a simple example of urea, CONH2. Now I don't know if you are not able to read this, that is completely fine, no need to worry about it. But for now, you must know that urea has carbon, oxygen, nitrogen and hydrogen in it. For now this much of knowledge is enough. And then there was a term which was named as inorganic compound. Let's read that. So okay, so there is nothing about inorganic compound. It means it should be organic, not inorganic. There is a mistake in the textbook. So they tried to synthesize a organic compound urea from another organic compound in the laboratory, and the new compound that was received had a new identity. Means it was a completely new molecule in this world. Now all the compounds having carbon as a constituent element are called as organic compound. So I hope if you got the definition of organic compounds, any compound that have carbon as constituent element, like important element, that is called an organic compound. The compounds such as carbon dioxide. Now there are some things that you must remember, because you are in a standard 10 now. So let me say that. So first thing is, when we talk about carbon dioxide, it is represented as CO and 2, right? Like there are two oxygens, CO2. Carbon monoxide, di means 2, so that is why it is having 2 oxygen. Carbon monoxide means single oxygen. So carbon monoxide, carbide salts, carbonate salts, and bicarbonate salts are exceptions. If you are not familiar with this name, there is nothing to worry about. You will learn about them. Now they are inorganic compounds of carbon. Okay, so you must understand that organic compound are those compounds which have carbon as a constituent element inside it. Okay, but that doesn't mean that any molecule that has carbon will be an organic compound. Okay, so there are some example of inorganic compounds of carbon also. Here it is written carbonate salts and bicarbonates. So yeah, just remember this. Now we will learn about bonds in carbon compounds. So you have learned about ionic compound in previous chapter. Okay, don't worry if you don't know. Like I know that we have not gone through previous chapter, but that is completely fine. Ionic compound means molecules that have positive and negative charge. Like one atom will be of positive charge and another atom will have negative charge, and they will be together because of the attraction force of opposite charges. So in that case, those are called ionic compounds. Now we also know that ionic compounds have high melting and boiling points, and they conduct electricity in the molten and dissolved state. The best example of ionic compound is NaCl. Now let me show you something. Okay, so what happens is, one second. So this is my plus and this will be my minus. Now there will be several, like ionic compounds are just like this. Every minus charge will be surrounded with the plus charge, and every plus charge will be surrounded with minus charge. It is a very simple example of ionic compound. Let me show you the diagram. Structure of ionic compound. So I hope you can see this diagram. Okay, we can learn about this diagram also. So this is the simple diagram of sodium and chlorine. I hope you know that NaCl is the name of sodium chloride, right? So if you will see this diagram, the smaller atoms, actually the orange color ones, are sodium, and the green color ones are chlorine. Now chlorine will have one negative charge, sodium will have one positive charge, and because of the attraction force they form a bond, and this is called an ionic compound. Now this attraction force are very strong, that is why they have high melting and boiling point. So, and they conduct electricity. It is very obvious, but only in molten and dissolved state. because if you keep them in molten state, these bonds will break. Okay, and then the electrons will be free inside the solution, so they will conduct electricity. Why? I don't know if you have heard of, but electricity is conducted from one place to another with the help of electrons only. Okay, so Cl minus, as I said, chlorine, right? Chlorine has a negative charge on it. So Cl minus is actually chlorine is a halogen. I hope you know that, and it is in the 17th group also. So it just needs one element to be precise. Sorry, not one element, one electron to get the configuration or to achieve the electronic configuration of a noble gas. Okay, so chlorine actually takes one electron and it becomes Cl minus. Okay, now let's go back here and see what is happening. You have also seen that these properties of ionic compound are explained on the basis of ionic bonds in them. It is very obvious, if the bonds are stronger, it will be harder to break them, and if the bonds are harder to break them, it means it will be having high melting and boiling point. Now, table 9.1 shows melting and boiling points of few carbon compounds. Okay, are these values higher or lower as compared to ionic compound? So if you will see, the melting point is in for degree Celsius, it is minus 183, minus 117 degrees Celsius, minus 64 degrees Celsius, and 17 degrees Celsius. Let's read the name of the compound. This is methane. Molecular formula is CH4. Now let me show you how methane looks like. So if you have to represent it, you can represent it in simple term like this, that one carbon is attached with 4 hydrogen. Okay, every carbon is attached with 1 hydrogen. Okay, let me draw the hydrogen here. So yeah, this carbon has 4 bonds, if you can see, and each bond is attached with hydrogen atom. So 1H actually stands for 1 atom of hydrogen, and 1C represents 1 atom of carbon. So if you have to represent it like then you will, like, if you have to write it on the paper, you will write it like this. But let me show you a 3D model, like the real diagram of methane. So methane is actually like this. I hope you can see this diagram. Okay, so yeah, this is your hydrogen atom. The sky colors, the blue color actually is the hydrogen atom, and the red color is nothing but the carbon atom. Okay, and each carbon is attached to 1 hydrogen. And please remember this, always, that 1 carbon maximum it will make 4 bonds. Any molecule of carbon, if you can see, they are making 4 bonds, right? So this is the structure of methane, 3D diagram to be more precise. Okay, so this is about methane. If we talk about ethanol, so if you can see, the molecular formula of ethanol is CH3CH2OH. So now let's understand how ethanol will look like. It is very simple. Let me show you. Ethanol, a structural formula. So if you can see, this is how ethanol will be. C2H5OH is the molecular formula. It means 2 carbon, 5 hydrogen, and 1 OH. OH is separate. You will learn it later why OH is separate. But if you want to see, this is the ethanol. I hope you can see this diagram. If you will see your textbook, what is the molecular formula for ethanol? CH3CH2OH. So if you will see, 1C is attached with 3H, right? this H, and this H. Then it is CH2. So again one C, and it is attached with two alcohol. Okay, no, sorry, not alcohol. It is attached with hydrogen. Now OH group is called alcohol group. If you don't know it, it is completely fine. For now, you just need to know that if I am having an OH group, it will be called an alcohol group. Now, the most important thing to note from this diagram is that here in this molecule also, one carbon is having four bonds, right? If I talk about first carbon, please see the diagram carefully. If I talk about the first carbon, it is having four bonds, one with this hydrogen, the other one with this, and the other one with this, and one within itself. The two carbon are linked with each other. Now this carbon also has four bonds, two with the hydrogen, one with the carbon, and one with the oxygen. And if you will see carefully, this oxygen has two bonds, one with the carbon, one with the hydrogen. So the important thing to understand here is a carbon will always make four bonds, a hydrogen will always make one bond, and oxygen will always make single bond. No, sorry, double bond. Okay, so this was how structural, like how to represent it on paper. So ethanol. Okay, now it is okay. Now let's see about chloroform. Chloroform's molecular formula is CHCl3. I hope you have heard about chloroform because it is used as an anesthesia. Give me 1 second. I will show you the structure of chloroform. Yeah. So this is the structure of chloroform. If you can see, one carbon. The black one is carbon. There are three chlorine. The green color is the chlorine, and there is one hydrogen which is of white color. So CHCl3 is the chloroform. Then we have acetic acid. The molecular formula of acetic acid is CH3 C double bond COOH, or we can also say CH3 CO2H. Now let me show you the structure of acetic acid. So as I said, what was the molecular formula? CH3CO2H, right? So you see, C means SEE. So you have to look here. So this carbon actually has three hydrogen, right? As given in the molecular formula. The molecular formula is for acetic acid is CH3CO2H. So this carbon has three hydrogen, and then one carbon. If you will read the molecular formula, COOH, right? It means that this carbon will have one oxygen, one more oxygen, and this will be with alcohol group. So you must know this, that CO2H, wherever you are seeing CO2H, is actually an acid. They might have different name, but they will always be an acid. So similarly, CO2H we are having here. Now there are two bonds between oxygen and carbon in this case, but please pay attention that even after making two bonds, they are not violating the rules. What are the rules? Each carbon will have four bonds. This carbon has four bonds. Each hydrogen will have one bond. All these three hydrogens have one bond. Even this hydrogen have one bond, but this hydrogen is linked with O, right? And what was the rule for oxygen? Each oxygen will have two bond. This oxygen also has two bond with the same carbon. It is possible, don't worry. And this oxygen also have one bond and one bond with hydrogen. So total it also has two bond. If you talk about this carbon also has four bonds. Two bonds with this oxygen, third with this one, and fourth one with this one. So carbon is actually having four bonds. This carbon is having four bonds. So these are the rules you must remember. So let's see about the melting and boiling point. Not much of concern, but yeah, it is important to know this. So these are basically some carbon compounds. Okay, methane, ethanol, chloroform, and acetic acid. Now let's see. Generally, the melting and boiling points of carbon compounds are found to be lower than 300 degrees Celsius. Okay, let us see that melting point and boiling point. Yeah, it is lower than 300 degrees Celsius. From this, you understand that the intermolecular attractive forces are weak in carbon compounds. How can we show that? See, the stronger the compound will be, the higher will it take to melt it. So the melting and boiling point of carbon compounds are less than 300 degrees Celsius. It means that the attraction force between intermolecular means between two different molecules is very less, and since the attractive forces are weak, and that is why the melting and boiling point of carbon compounds are also low. And if we talk about the data, it is lower than 300 degrees Celsius. This is the first piece, that is, it is important for me to explain you everything. Now let's read the next line. In the previous standard on testing the electrical conductivity of carbon compounds, glucose and urea, you have observed that they are not electrical conductors. Okay, you must have done this in last class. Now, generally, most of the carbon compounds are found to be bad conductors of electricity. Okay, so this is one important line that you should know, that most of the carbon compounds are found to be the bad conductor of electricity. From it, we understand that structure of most of carbon compounds lack ionic bond. Okay, why can we understand this? Because ionic bonds are like if you talk about ionic molecules, they are good conductors, right? But it is saying that most of the carbon compound are found bad conductor of electricity. It means that carbon compounds have bonds. Okay, it means that the chemical bonds in carbon compounds do not produce ions. Now, what is ions? Ions is nothing but the charge. Electron, positron, they all are negatively or positively charged, respectively. So, what is it wants to say is, if you talk about carbon compounds, since they lack ionic bond, they will have, like, they do not produce much ions, and since they do not produce much ions, they are a bad conductor of electricity. So you have to understand this. Now there are some questions. What is meant by chemical bond? Chemical bond means a bond that is found between two atom or two molecule. What is number of chemical bond that an atom of an element forms called? Okay, this is an interesting question. Number of bond that an atom of element can form. So this answer actually will take you to the chapter periodic classification of element. You try to find the answer of this question, and if you can't, let me know. What are two types of chemical bonds? The answer of this question is covalent bond and ionic bond. I have explained about the ionic bond and I have not explained about the covalent bond. Don't worry, I will explain it later. Let's read what is coming first. In the previous standard, I don't know why it is going back to previous standard. Okay, you have learnt about the relationship between electronic configuration and valency of an element. Yeah, I hope I have taught you electronic configuration and valency of an element, and also about ionic and covalent bond. Okay, it means you have already learned about ionic and covalent bond. Then it is completely fine. Let's see at the background of electronic configuration of carbon and covalent bonds formed. Okay, let's see this table then. Carbon atom, yeah, carbon atom, C6. Okay, it means 6 is the atomic number, and if 6 is the atomic number, it means it has 6 electrons. It means it has 6 protons. Okay, now what is the electronic configuration? Electronic configuration is how the electrons will be placed in the shell. So the first shell will have second 2 electron. The second shell can have 8 electron, but after giving 2 electron to the first shell, this carbon will have only 4 electron because the total is 6 electrons. So the 4 electron will come into the second cell. So second cell will become outermost shell. So it will become the valence shell, and the number of electron in the valence shell is called valency. So that is why the valency becomes 4. Now what are the nearly noble gas and in the electronic configuration? Now the noble gas is helium and neon, the two noble gas that are closer to carbon. For this you need to check your periodic table. Let me show you periodic table. I have this periodic table here. Let it load. If you can see, this is your carbon, right? Here is your carbon, and the element closer to carbon, the noble gases, one is neon and the upper one is helium, because if my carbon is here, it can also lose some electron and achieve the configuration of helium, or it can achieve the configuration of neon. So if you will see, let's go to the chapter and see what it wants to say. You have seen that the driving force behind the formation of bond by an atom is to attain the stable electronic configuration of the nearby noble gas and obtain stability. So I told you, right, every element wants to have full electrons, that is 8 electrons in their valence shell, so that they can have an electronic configuration of noble gas. So similarly, any atom, like maybe it is metal or non-metal, it always wants to have an electronic configuration of nearby noble gas. Why? Because it is stable and it will provide stability. Everyone wants to be stable, right? So similar applies with the atoms. Now, as the valence shell of carbon contains 4 electrons, there can be many alternative routes to attain a noble gas configuration. Okay. Now, since the carbon has 4 electrons in the valence shell, it can give 4 and attain a configuration. It can also take 4 and attain an electronic configuration. Now, let's see. Now, to attain the electronic configuration of noble gas helium by losing one after another all the 4 valence electrons. Why? Because atomic number of helium is 2. Right? So if it has to achieve the configuration of helium, it will have to lose all its 4 electrons. So if it does that, the net positive charge, because it is losing electron, number of proton will be fixed, right? Because it is inside the atom and electrons are revolving around the nucleus. So if it is losing electrons, protons will become more. And if it loses 4 electrons, it means it will have 4 more protons. It means it will have 4 positive charge on it. Now what happens that to attain the configuration of noble gas helium by losing 4 electrons, that is 4 valence electron, in this method the positive charge on carbon atom goes on increasing during loss of every electrons. Therefore, to lose the next electron, more energy is required, which makes the task more difficult. Moreover, the C4 plus cation that would ultimately form in this process becomes unstable in spite of its noble gas configuration. So the scientists found that if the carbon loses its 4 electrons, it will have 4 positive charge on the carbon atom, right? 4 positive charge means 4 cation. Cation means positive charge. So 4 positive charge on one atom would be very unstable, even if it is having electronic gas configuration. Noble gas configuration. Even if the carbon will achieve noble gas configuration, 4 positive charge on carbon will make it very stable, because the carbon is of very small size. If you will see the carbon, it is actually in the it has 2 shells only. So if it will lose 4 electrons, it will reach to the part of first shell, and this is very unstable for an atom. So therefore, carbon atom does not take this route to attain a noble gas configuration. Okay, I think you understand this. Since this step of losing 4 electrons and achieving the noble gas configuration of helium will lead to carbon having 4 positive charges, it will make it very unstable, and that is why carbon atom does not lose 4 electrons. It does not follow this path. So let's see the second one. Now to attain the in one word, I can explain this paragraph in one word. You have to focus here, okay? So what will happen if carbon wants to achieve the electronic configuration of neon? If you see the diagram, carbon is having how many? 6 is the atomic number of carbon, and neon has 10 atomic number. It means carbon needs 4 electrons to achieve the electronic configuration of neon. Why is that so? because you can see in this table that neon is having 2,8, carbon is having 2,4. If it gets 4 more electrons, it will reach to 8, but 4 electrons means 4 negative charge, and again 4 negative charge on an atom is very, very, very unstable. Okay, so carbon doesn't follow this part too. Now let us read it. To attain the stable configuration of noble gas neon by accepting one by one as the 4 electrons in the valence shell, in this method the net negative charge on the carbon atom goes on increasing. Why negative charge is increasing? Because it is accepting electrons. So what will happen? More energy is required for accepting the next electron by overcoming the increasing repulsive force, making the task more difficult. Let me show you this by diagram. So let's say this is an atom of carbon. Okay, yeah. Now let's say it has one negative charge. Okay, so if carbon wants one more negative charge in its outermost shell, what will happen? It will try to bring this electron in the outermost shell, right? But these are negative charge and this is also negative charge. These both electrons are negative charge, so they will repel each other. I hope you have learned that. Positive, opposite charges attract, like charges repel, unlike charges attract. So similarly, it will repel. Even if let's say even if I had 2 negative charges, and let's say it has to third negative charge, what will happen in this case? If I'm having third negative charge, the atom will try to accept this negative charge into its outermost orbit, but this won't be possible because there are already 2 negative charges on the outermost shell. So they will again repel each other. Repel means they will not allow this electron to enter into the orbit because they are of same charge. So similarly these things happen. So that's why, that is what it is written, like more energy is required for accepting the next electron because it has to overcome the increasing repulsive force, making the task more and more difficult. The repulsive force is actually given by these electrons which are already present there. Okay, so these negative forces will try to repel each other. So when so it is called repulsive force because it is repelling. These 2 electrons will try to repel this electron, even if the atom wants it, but the outermost electron will say no, you are not allowed to go because you are having the same charge as mine. So that is why C4 minus anion. Anion means negative charge. So C4 minus anion formed is unstable even if it has noble gas configuration, as it would have a very small size with a high net charge. I told you why the size is small, right? And it will have high net charge means it will have -4 charge. So it will become very difficult, +6 to hold 10 electrons around it. And yeah, the nucleus charge will be having +6, but inside the nucleus of carbon, it will have 6 protons, right? So if there are 10 electrons outside it, what will happen? The attraction force will increase. So that is why, and that is when the atom will become very unstable, and therefore carbon atom does not take a route to attain noble configuration. So losing is rejected, gaining is rejected. So what will the carbon do then? So see, to attain the configuration of neon by sharing 4 electrons of valence shell with 4 valence electrons of other atom. Now what it wants to say that in this method 2 atoms share valence electrons with each other. Valence electrons means the electrons in their outermost shell. They will share, they will not occupy. Please understand this. Having a negative charge or accepting an electron means you are the owner of it. But when you are sharing, it means you can use it, and the other person, like the one who owns it, can use it too. So valence shell of both the atom overlap and accommodate the shared electrons. As a result, both the atoms attain a noble gas configuration without generating any net charge on them, which means that atoms remain electrically neutral. Electrically neutral means there will be no positive charge, there will be no negative charge. And due to these factors, atoms attain a stability. Therefore, carbon atom adapt this route to attain a noble configuration. Now, you must have understood when I said that each carbon will have 4 bonds, right? This bond, can you see? These are bonds. I have shown you the diagram, right? So any carbon is having 4 bonds because it is sharing its electron. Like it has 4 electron in its valence shell. So it will use hydrogen's electrons also, and it will share. Whenever required, it will share. So similar, that is why they are making 4 bonds. Let me show you it with the diagram. So please pay attention. I'm talking about CH4, that is carbon and hydrogen. Now we all know that hydrogen has 1 electron, right? So let's say the electron, okay, I can say this here. So let's say this is the 1 electron of hydrogen. This is also the 1 electron of hydrogen, and this hydrogen also has 1 electron, and this hydrogen also has 1 electron. Now what will happen? This carbon will have 4 electron in its valence shell, right? So this will be the diagram. Now if you will see, these electrons are of carbon, okay, but in the whole molecule, if you talk about the whole molecule, each bond, this is the bond, okay, each bond is sharing 2 electrons. So basically carbon has 4 electrons plus 4 electrons of hydrogen because it is sharing. So the total becomes 8, and this will become stable. If you talk about hydrogen also, if you will see, since this is shared, this is not owned by someone, so this hydrogen atom which is present here will also have 2 electrons in the sharing, right? And since hydrogen has only 1 shell and the first shell needs only 2 electrons, hydrogen will also achieve a stable configuration. So this is how carbon attains stability. Okay, they try to share the electrons instead of acquiring them like sodium or chlorine. Like sodium will lose it all, that is why it becomes Na plus. Chlorine will accept it, that is why it becomes Cl minus. So I hope you now understand this. Here the carbon is actually sharing it. Now let's go back and read. Okay, so therefore carbon atom adopt this route to attain a noble gas configuration. It is a very important question that why carbon doesn't lose or gain electrons, and why does it share? So the answer is also very simple, that the size of carbon is very small. So 4 positive charge, that is 4 cations, or 4 negative charge, that is 4 anions, will not suit it. It will not be stable. That is why carbon shares it. Now chemical form, this line is very important. I don't know how to highlight this, but the chemical bond formed by sharing of 2 valence electrons between the atoms is called covalent bond. So these are my valence electron, right? Because they are in the outermost shell. Because you must know that in bond formation, inner electrons, like the electrons in the inner shell, do not participate. Only the valence electrons participate. So since the bond is formed and the valence electrons are participating, both in the carbon and hydrogen. So in this case, like the chemical bond formed by sharing of 2 valence electron between the 2 atoms is called covalent bond. Very important answer. I hope you now know what is a covalent bond, and I have already told you what is ionic bond, like the bond which happens or which forms because of the 2 opposite charges attracting each other. If you will see, there are no charges, like there is no negative charge, positive charge. This is not the case with NaCl. With NaCl, what happens is, just thought to take it out of the structure. Yeah, every chlorine will have a negative charge and every sodium will have a positive charge, and that is why they form an ionic bond. Because of the charges, they are very stable. Tell me why? Okay, if chlorine has a negative charge, if you see the periodic table, and if the chlorine has a negative charge, if you will see, chlorine after having 1 electron will achieve the configuration of the noble gas argon, right? So it will not try to share it. It will keep it with itself because it is more stable. And similarly, like sodium, if you will see, sodium by losing just one electrons, it will achieve the configuration of neon. So they stay in their negative and positive charge only. They do not form bond, and that is why. But the thing is that when the bond is formed, and in the attraction force, like for the negative and positive charge, the attraction force is very high, so they have high melting and boiling point. But when there is a bond, covalent bond, what is the covalent bond? Bond formed by sharing of valence electrons. They are not as strong as the ionic bonds. So that is why covalent compounds have temperature lesser than, like melting point and boiling point, lesser than ionic compound. This sentence was already there. Now let's read about this line. Okay, they have shown here. So a covalent bond is represented clearly by drawing an electron dot structure. You must remember what is dot structure. In this method, a circle is drawn around the atomic symbol and each of the valence electron is indicated by a dot or cross. If you can see, I have a hydrogen. This is the atom of hydrogen, and this one dot that you can see of blue color is actually the electron in it. This is also a hydrogen atom. Just to make some difference between them, they have given different color so that it becomes easy to understand. And this is the nucleus of hydrogen atom. This is the electron. So hydrogen H and H, two H can also combine to form a molecule H2, and if you will see, they will have two electrons, right? So they can share, this electron will share it with this one, and sorry, this atom will share the electron with this one, and this atom can share its electron with this one and form a molecule called H2, that is a hydrogen gas. I hope you are familiar with what is hydrogen gas. So this diagram is actually electron dot structure, okay, and this is line structure. When you draw H and give a bond, you can see this is single bond. Let me show you then. This is the double bond and this is single bond. Okay, so this is line structure, what I have just drawn. This one is actually called line structure. Okay, now I hope there are no doubts on this page and this page. Since this is beginning, if you do not understand anything, please highlight it or please ask me in the classroom. Okay, now let's go to the next page and let's try to understand what is it saying. It is saying that let us first look at the hydrogen molecule, which is the simplest example of molecule formed by covalent bonding. Covalent bonding means any bond that is like any molecule that is formed by covalent bond. So you have already learned that atomic number of hydrogen being 1. Okay, so atomic number is 1, so it will have 1 electron, and the innermost shell is called K shell. K shell requires 2 electrons. It has already 1. So what will happen? It requires 1 more electron to complete the K shell and attain the configuration of helium. Why? If you see the periodic table, you see hydrogen is on the topmost, right? The atomic number is 1. It means it has 1 electron. But if you see helium, which has the same number of shell, that is 1 shell only, but it has 2 electrons, so it is in the series of noble gas, right? Helium, neon, argon, krypton, xenon, radon. These are actually noble gases. So by just having 1 more electron, helium becomes a noble gas. So hydrogen also, to achieve the noble gas configuration, so to achieve the electronic configuration or of noble gas helium, tries to have 2 electrons. So to meet this requirement, 2 hydrogen atoms share their electrons with each other to form H2 molecule. Okay, now see, this is oxygen. Okay, this is not a good example, but this was actually a good example. Each hydrogen having 1 electron sharing with each other, becoming H2 because 2 hydrogen atoms are there, right? So they are both are having 2 electrons, having a stable configuration. Now let's see what is it trying to say. So to meet this requirement, 2 hydrogen atoms share their electron with each other to form H2 molecule. Now one covalent bond, that is a single bond, is formed between 2 hydrogen atoms by sharing of 2 electrons. Very important line. You should understand. When there is one covalent bond formed, it means that they are sharing two electrons. Here also, if you will see, I have shown you in the diagram, right, that two electrons are shared with this bond. So that is the case. Yeah. Now let's try to read what. Okay, the next is about O2. O2 is nothing but oxygen that we inhale. So the O2 molecule is formed by chemical combination of two oxygen atoms, and two molecule, that is nitrogen, is formed by chemical combination of two nitrogen atoms on drawing the electron dot structure. Electron dot structure means what? You will draw the atom, you will draw the outermost shell, you will put the electrons like this, and then you will try to see. So this is actually atoms of oxygen. If you see the periodic table, what is the oxygen, what is the atomic number of oxygen? It is 8, right? 8 is the atomic number of oxygen. And how much electron does it needs to attain the noble gas configuration? So the noble gas configuration, the noble gas which is closer to oxygen is nothing but neon. Okay, so the neon has atomic number 10, oxygen has atomic number 8. It means oxygen has 8 electrons, neon has 10 electrons. So oxygen needs 2 more electrons to achieve the noble gas configuration. So what oxygen does is, please look here. Okay, so O2 molecule is formed by chemical combination of two oxygen atoms and two formed by two nitrogen atoms. On drawing the electron dot structure of these two molecules, it becomes clear that two oxygen atoms in O2 are joined with each other by two covalent bonds. It is very important. See, oxygen is having how many electrons? Two. If you will see my diagram, okay, please focus here. So yeah, oxygen is having 8 electrons, right? Because the atomic number is 8. I don't know what is the atomic number of oxygen. Yeah, it is 8. Okay, but it will have 2 electrons in the innermost shell, that is K shell. So 6 will remain. So there are 6 electrons for this oxygen atom and 6 electrons in the valence shell for this oxygen atom. Both of them need 2 electrons. So what will happen? This both will share their 2 electrons. I hope you can see this diagram. So this both are sharing their 2 electrons with each other. So to share, like when they share 1 electrons, it form one. Like if carbon is sharing 1 electron of its with 1 electron of hydrogen, it forms a single bond, right? But with this, it is getting 1 electron from here, 1 electron from here, and 1 electron from here, and 1 electron from here. So he's getting 4 electrons. Carbon is getting 4 electrons, but oxygen wants 2 electrons. So oxygen is not, now if 2 oxygen atom in themselves, they form 2 bonds. Okay, so what happens is, can you see this? There are 2 electrons of this oxygen atom and 2 electrons of this oxygen atom. So they start sharing with each other their own 2 electrons like this. 2 to 4 and 4 8 if it is needed here. 2 to 4 and 4 8 if it is needed here. So since there are 4 electrons shared with each other, if you see properly, it forms 2 covalent bond, because one bond will have 2 electrons, right? Like let's talk about this first bond. It will have 1 electron from this oxygen, 1 from this oxygen. It needs 2, right? It is getting 1 from here. It needs 1 more. So what it will do, it will combine with this one, because this one also needs 1 more. So they form a double bond, and that is why O2 gas is formed, which we are inhaling. Now there is also a case of triple bond which arises with nitrogen. If you will see, nitrogen actually has 5 electrons in the outermost shell. So, and it needs 3 more, right? Because 8 is required. And if there are 5 in outermost shell, what nitrogen does is, it shares its 3 electrons with the 3 electrons of other nitrogen atom. And similarly, the second nitrogen atom will share its 3 electrons to the first nitrogen atom. So since there are total 3 electron share from its side, it needs 3 bond. I hope you understand this diagram. Now okay, atomic number of chlorine is 17. What is the number of electron in the valence shell? These all things, please do it and ask me if you have any doubt. Please do it, but it will clear your concepts. I have always told you to do this, even in the classroom. Now let us consider a carbon compound CH4. Now We should be now familiar with the molecular formula of CH4, which is methane, right? If you see, this is actually CH4, right? There is one carbon. Oh my god, what is this? And there is one hydrogen. So yeah, this is actually molecular formula of CH4, and this is the common name. Every molecule has a common name. So common name of CH4 is methane. So you have learned about the occurrence, properties, and uses of methane molecule in previous standard. Okay, it means you are familiar with CH4. Just now we saw that carbon atom forms four covalent bond using the four valence electron and attain the configuration of the nearby noble gas neon and obtain stability. Figure 9.5 shows the line structure and also the electron dot structure. Okay, where is the figure 9.5? Okay, try to read this and try to solve this question again, I will say. Yeah, very good. There is an excellent diagram on methane, if you will see. I hope you all can see this diagram. Very important diagram, and it is very necessary to understand this. So what I have done is, this is electron dot structure and this is line structure. This is what I have drawn, right? I have drawn this one, but let us understand the electron dot structure. If you see, this is one hydrogen atom, it has one electron. This is also one hydrogen atom, it has one electron. This is one hydrogen atom, it has one electron. This is the carbon atom. Since the atomic number is 6, it has 6 electrons, 2 in the innermost and 4 in the outermost. So what happens is, each of this electron is shared with hydrogen. Can you see? There is a covalent bond formed because hydrogen's one electron and carbon's one electron is forming a bond with hydrogen. So what happens is, there are 4 covalent bonds formed for each hydrogen because each hydrogen will need one electron and carbon needs 4. So it can only take one from one hydrogen. So it will combine with hydrogen, 4 hydrogens, to fulfill its need. So that is how 4 covalent bonds are formed, and it is called CH4 because there is one carbon atom and 4 hydrogen atom, and the common name is methane. I hope you understood from till this much. Now let us read about carbon. It is saying a versatile element. Okay, versatile means it can adapt to any situation. If you will see here, they have given a ball and stick model, one ball. They are actually trying to show you the real structure of methane, because one carbon is attached here with 4 hydrogen. Similar is this case. So just remember the model, it won't be asked anywhere, but you should know this. So this one is space filling model, this one is ball and stick filling model. We saw that carbon atoms, like some other atoms, share the valence electron. Now what are the other atoms here? We just read, hydrogen does by forming a single bond, oxygen does by forming a double bond, and nitrogen does by forming a triple bond. So like carbon, there are some other atoms also that share the valence electron to form covalent bond. Similarly, we also saw the structure of simple carbon compound methane, but carbon is different than other elements. Why? The number of compounds formed from carbon is extremely large. Okay, in the beginning we saw that except for the objects formed from metal and glass soil, all other objects are made from carbon. Okay, in short brief, the entire living kingdom is made from carbon. This is actually a very big sentence. You must note it. Our body is also made from carbon. Millions of molecules ranging from small and simple methane molecule to the extremely big DNA even are made from carbons. Okay, the molecular masses of carbon compounds range up to 10 to the power 12. Okay. So this means that carbon atoms come together in a large number to form extremely big molecules. Okay, what is the cause of this unique property of carbon? Okay, the author, the scientists were curious that why only carbon was able to form this many number of molecules. It is due to the peculiar nature of the covalent bonds formed by carbon. It can form large number of compounds. Okay, so they are saying because of the nature of carbon and the bond, the covalent bond that it forms with other atom, it is able to form large number of compound. Okay, from this we came to know about characteristic of carbon. Okay, let's read this. It is important. A carbon has a unique ability to form strong covalent bonds with other carbon atoms. Okay, interesting. So carbon can actually form a bond with carbon only. Okay. So this result in formation of big molecules. This property of carbon is called catenation power. Important definition. You should remember. If asked what is catenation power, you have to define these lines like carbon has a unique ability to form a strong covalent bonds with other carbon atoms. This result in formation of big molecules. This property of carbon is called catenation power. Okay. The carbon compounds contain open chains, closed chains of carbon atom. Now I completely understand if you do not get what is open chain and closed chain, but you need not worry about it. You will read it. An open chain can be a straight chain or a branch chain. Okay. Open chain has two categories, straight and branched, and a closed chain is a ring structure. Okay, so these are actually the structure of carbon compounds. The covalent bond between two carbon atoms is strong and therefore stable. Please note, when they are saying strong, it means they are just strong. They are not saying that they are stronger than the ionic bonds. Okay. Now, due to the strong and stable covalent bonds, carbon is bestowed with catenation power. Okay. So, what the scientists found that carbon has a unique property of forming a covalent bond with other carbon atoms. And then notice that this bond, like the bond which is formed between two carbon atoms, or to be more precise, the covalent bond which is formed between two carbon atoms is having like they are strong, so that is why they have the catenation power. What is catenation power? I have already defined it. Now let's see this. Okay, methane, these are the carbon compounds. So methane, cooking gas, benzene, camphor, penicillin, sugar, sodium rhodocyl, benzene sulfate, fat, starch, cellulose, protein, polyethylene, DNA, and these are the molecular masses. You will be surprised to see that DNA has molecular mass which values up to 10 to the power 12, and methane, that is CH4, the smallest carbon compound. Please remember, it can be asked in fill-ups and all. So the smallest carbon molecule compound is actually CH4. It has a molecular mass of 16. I hope you know how to find molecular mass. So two carbon atoms can be bonded together by 1, 2 or 3 covalent bond. These are called single bond, double bond and triple bond respectively. It means when two carbon atoms are bonded by one bond, it is called single bond. When they are bonded by double bond, it is called, like when they are bonded by two covalent bonds, so it is called double bond. And when they are bonded by 3 covalent bonds, it is called triple bond. Now due to the ability of carbon atoms to form multiple bonds as well as single bonds, the number of carbon compounds increases. Okay, so what is it saying is that the carbon atoms, since they have ability to form multiple bonds and even also single bond, and that is the reason why the number of carbon compound is found higher in the nature. Now for example, there are 3 compounds. Let's see them. Ethane, that is CH3CH3. Okay, then we have ethene, that is CH2 double bond CH2, and then ethyne, that is CH triple bond CH, which contain 2 carbon atoms. If you see here, all these 3 molecules have 2 carbon atoms only, but they are 3 different molecules because one of them is forming one single bond. Okay, so I was discussing about ethane, ethene and ethyne. So you must remember the name. Ethane comes when the carbon and carbon are bonded with single bond. Ethene comes when carbon and carbon are bonded with double bonds. And ethyne comes when carbon and carbon atoms are bonded with triple bonds. So being tetravalent. What is tetravalent? Tetravalent means tetra means four and valent means bond. So since they have capability to form four bond, one carbon atoms can form bonds with four other atoms. It can be the four other atoms can be carbon or can be any other atom, which result in formation of many compound which possess different properties as per the atoms to which carbon is bonded, which is correct. Now, for example, five different compounds are formed using one carbon atom and two monovalent. Monovalent means single bonded. Tetravalent means four bonded. Carbon is a tetravalent atom. Hydrogen is a monovalent atom because hydrogen can form one bond only. So, and two monovalent elements, hydrogen and chlorine C. CH4, CH3Cl, CH2Cl2, CHCl3 and CCl4. Now Cl actually stands for chlorine. So here one carbon is attached with the four hydrogen. Here one carbon is attached with one chlorine and three hydrogen. Here one carbon is attached with two chlorine and two hydrogen. In this, one carbon is attached like bonded with three chlorine and one hydrogen, and in this one carbon is bonded with four chlorine atoms. So similarly, carbon atom form covalent bond with atoms of element like oxygen, nitrogen, sulfur. Halogen means fluorine, chlorine, bromine, iodine. These all are halogens, and P, that is phosphorus, to form different types of carbon compounds in large number. Okay, carbon has one more characteristic which is responsible. Okay, they are not responsible, that is why their spelling is wrong. But we are responsible, right? So let us learn. So carbon has one more characteristic which is responsible for large number of carbon compound. It is isomerism. I know you will find it hard and you don't know about it, but that is completely fine. We will learn about it later. Our next topic is hydrocarbons and saturated and unsaturated. So we'll probably continue the next topic in this lesson, next class. For now, 1 hour 2 minutes video for carbon atoms I think is enough. Please ask me if you have any doubt, and please make a note of the important point that I am discussing. Thank you so much.